Myself, Dr. K. Viswanath Allamraju, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today we are going to study and learn how to draw a cam profile of a flat-faced follower having a motion of simple harmonic motion and it is offset by 15 millimeter. Offset by 15 millimeter. So, what are the conditions? The motion of the follower is a simple harmonic motion. The outstroke angle theta equal to 60 degree, and after the outstroke and the dwell after the outstroke is 30 degrees, and the return stroke is, we can make it as it is 120 degree, 30 degree, and return stroke, the angle of rotation of the return stroke is 60 degree, and the remaining angle is dwell during the return stroke, theta or d, that is 150 degree. So, and here in this case, the axis of the follower is offset by 15 millimeter from the camshaft axis or from the camshaft, and the stroke of the follower or the length of the stroke of the follower is 50 millimeter. And another condition is that the minimum radius of the cam is 25 millimeter. The length of the face of the follower, that the flat face, is 20 millimeter. So these are the conditions we have to draw. First, displacement diagram. The motion of the follower during outstroke and return strokes. The motion of the follower is simple harmonic motion. So how to draw the cam profile? First, before going to draw the cam profile, the requirement is that displacement diagram. The motion of the follower, it is simple harmonic motion. For that, take a scale. The scale for displacement diagram for x-axis. On x-axis, we consider the rotation of the cam. On y-axis, we consider the lift of the stroke or stroke of the follower, that is 50 millimeter. Now here, we consider 20 degrees equal to 1 centimeter. Then the outstroke becomes 6 centimeters. Theta OD becomes 1.5 centimeter. Theta return after conversion to this scale, that is 3 centimeters. Theta dwell during return, that is 7.5 centimeter. So total we have to draw with this. Draw a horizontal line, and that is the length of, that is outstroke. The length of outstroke is how much? That is 120 degrees. 120 degrees means 6 centimeters. Then theta outstroke dwell, that is 30 degrees. Theta return stroke, that is 3 centimeters. That is return stroke is 60 degree. We have to mention here in terms of degrees, even though we are using the scale. And the remaining is return stroke dwell, that is 150 degrees. That is the horizontal line, x-axis, and y-axis, that is 50 millimeter, nothing but a 5 centimeter. this is the length of 50 millimeter. There is a stroke or lift of the follower. After that, draw this horizontal lines on the top also. So draw vertical lines. So I am using here with a free hand, but you have to draw using geometric instruments. So it is SHM. So divide this outstroke, the length of 6 centimeters, into 6 equal parts, even number of parts. Again, once again I am repeating, we can divide even number of parts 4, 6, 8, 10, 12. But the optimum even number of parts are 6. So divide this equally. So mark it as a point A. 1, 2, 3, 4, 5 and 6. Draw vertical lines. Okay. So this is similarly outstroke also, return stroke also, we have to draw equal number of parts. Okay. Now after drawing these vertical lines for SHM motion, how to draw the SHM motion line? Draw a semicircle to the one of the vertical. Divide the semicircle into equal number of parts, that is each angular part indicates 30 degrees. Then mark these equal parts into small letters, it is the PQRS, whatever required points. So I am marking here, here it is P, Q, R, or you can give in terms of 0 and 0, it is 1, 2, 3, 4, 5 and 6. Draw a horizontal lines. Draw horizontal lines and intersecting the one line is the 1, 2 with the 2 vertical lines and 3 with the 3, 4 with 4, 5 with the 5, 6. These are the points, name it as requirement, whatever points you want, and you can make it as small. This is join as a small letter A, B, C, D, E, F. Join all these points with a smooth curve. This curve comes, this is the SHM motion curve. Transfer these points into the return stroke, from outstroke to return stroke. Then equal number of points. And after that, join that curve. So again, okay, it will come. This is the point. So these are the lines. What are these lines are? You can mark it as same number of lines. Here it is 6 dash, 5 dash, 4 dash, 3 dash, 2 dash, 1 dash, 0. So this curve gives the displacement of motion of the simple harmonic motion of the follower. This is the displacement curve. when the follower is having a simple harmonic motion during outstroke and return stroke. This is during outstroke and return stroke. This blue color indicates the return outstroke and return stroke curve complete during SHM motion. Now this is once again what is the first step? First you have to draw the scale, take scale, convert this outstroke, identify the outstroke, dwell after outstroke, return stroke, and angle of rotation of the dwell during return stroke. Find out after identifying, convert into the scale and draw the x-axis and y-axis and complete the rectangle of both top and bottom, and divide this once lift a stroke of the follower into a semicircle and divide into equal number of even number of parts. Same number of parts divided for display outstroke and return stroke also, and join the horizontal and vertical lines. That intersection gives the path of a follower during angle of rotation of the cam. This A point indicates, for example, this is the 120 degrees, that means 6 parts, that means each 20 degrees. So for 20 degrees, the lift of the follower moves up, rises up to point A. For the next 20 degrees, again point B, next again 20 degrees, point C, 20 point D, next like that. By adding of 20 20s, it goes from capital letter A to small letter A, B, C, D, E and letters F. And during return, the same points, it is E dash, D dash, C dash, B dash, A dash and capital A. So during return stroke, it is comes down, goes down. That return stroke indicates from 6 dash. For after dwelling means there is no motion of the follower. For next rotation of the cam, 20 degrees. That is indicates here 120 plus 30, 150. After next 20 degrees, 150 plus 20, 170, it comes to E dash. Next 190 degrees comes to D dash, 210 degrees C dash. Again rotation of 210 plus 230 B dash, 250 A dash, and 270 it comes to A dash. So like that it comes back 150 plus like that 3, it goes back 120 plus 30, 150 plus 60, 210. So for the 210 it return stroke, it comes. They again remaining angle 150 degrees, it remains a dwell. There is no motion even though cam may be rotating. So this is the SHM motion. How it looks like that with simple harmonic motion. This is the curve, it looks like that. So for exactly this is the angle of rise, outstroke, and the outstroke angle, again return stroke. This is the curve of the simple harmonic motion. So we are considering now the case of offset follower. It is offset by 15 millimeters. So offset by 15 millimeters. How to consider? How to draw? First, draw the minimum radius of the cam, that is 25 millimeter. Minimum radius of the cam, that equal to 25 millimeter. With this 25 millimeter, draw the circle with this radius. With the help of the compass, you have to draw. This is the base circle, but there is offset circle is there. That offset by 15 millimeters. Offset by 15 millimeters. Draw the offset circle. This is 15 millimeters radius. Now, by touching the offset circle, draw a axis line, vertical line, and intersecting the point of the base circle, that point where this, what is there? This flat faced follower is in touch. Now the flat closure follower, that is for 20 millimeter, 10 and 10. This is the flat facer follower. Now divide this base circle into outstroke, dwell, return stroke, and dwell during return stroke angles. This divide base circle, that is, what is the outstroke? That is 125 degrees. Now join this point center to this intersection point. This is our reference line. Now what is 120 degree? I am drawing approximately here. This is 120 degrees. Next again 30 degree. Again 60 degree. And remaining angle is 150 degree. That is outstroke, OD, and return stroke. This complete portion is return stroke dwell. Now divide this, the circumference of the base circle, into even number of parts, that is 6 equal parts. Mark this equal parts, equal angular displacement. This is 1, 2, 3, 4, 5, and it is 6. Dwell, there is no division, and return stroke also divide into equal 6 equal parts. Again it is 0 dash, 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, and 6 dash. Now what to do? Very important. In the case of radial lines, we have drawn the radial lines. Now we have to draw, in the case of offset circle case, we have to draw a tangential lines passing through these division points, divided points. So draw a tangential from tangential to the offset circle. Similarly, draw the tangential lines passing through the lines which I am drawing approximately. You can continue. Okay. Now these are the points where we have to mark the displacement distances from displacement diagram. So it is 1 to B distance is there. Rather mark the points from 1 to B approximately. Next 2 to C. It is the 2 and it is the point C. Changing the color. This is point C, is point B. Next point 3 to this distance, point 3 to D, mark with the help of the compass. Next 4 to E, and 5 to F, and again 6 to G. You have to do it with the help of geometric instrument, that is compass. By using compass, you have to mark all these distances from the displacement diagram to onto this tangential lines which are drawn from the offset circle. Similarly, transparently we have to draw same procedure. You have to follow from that 0 to H, this is the 0 dash and H line, and 1 dash to J point, this is the 1 dash to J, 1 dash to J, again 2 dash to K, again 3 dash to 4 dash, 5 dash to 6 dash, like that. Now these are the points where the follower is in touch with. That's why we are drawing here the shape of the flat face follower. The flat face follower is the length of the flat face follower is 20 millimeter. So draw a 20 millimeter flat faced follower. Now at this point you draw normal to the surface 20 millimeters. It may intersect each other points. It should be exactly normal to the radial lines. These tangential lines are normal. Similarly, so these are the points. After drawing, automatically you have to draw a smooth curve by touching the surfaces of the follower, flat faced follower. That shape gives the shape of a or profile of a cam. This is the profile of a cam. I am drawing approximately by touching. This is the profile of a cam. When the follower is having a motion of simple harmonic motion and the type of follower is flat faced follower. So this is the procedure to draw the cam profile of the follower when it is under simple harmonic motion during outstroke and return strokes. So this why we have drawn here tangential lines to the offset circle. There are two types of circles are here. This is the base circle and there is another inside circle, that is offset circle. So this is the axis, offset axis. So for offset axis, the motion is that tangential to the tangential curves you have to draw. Whereas the axis of the follower is passing through the axis of the shaft. Then in that case, we have to draw the radial lines from the center of base circle. Offset circle doesn't come into the picture. Do not come into the picture. Now here, this is the way. This is the case for when the outstroke and return stroke both are with simple harmonic motion. Suppose if the case study is that, if the case is that during outstroke it is simple harmonic and return stroke uniform velocity motion. In that case, how to do it? The same set of offset circle. So for offset method, the procedure is same, but the displacement diagram will be changed. What is the case study? What we are doing? During outstroke, the follower motion is SHM and return stroke, the follower motion is uniform velocity. In that case, what will happen? Take same scale, draw the horizontal line, divide this horizontal line with equal. The scale of that outstroke is 120 degree and dwell after next return stroke. This is outstroke 120 degrees length, that is 6 centimeters. Dwell during outstroke, that is 30 degree. Return stroke, that is 60 degrees. Return stroke remaining dwell, that is 150 degree. Now draw these equal parts, vertical lines, even number of parts. That is as usual we mentioned. That is 6 parts. This is outstroke is SHM and return stroke is uniform velocity. So divide return stroke also equal number of parts. Mark these parts 0 or A up to your choice 1, 2, 3, 4, 5, 6. So 0 dash, 1 dash, 2 dash, 3 dash, 4 dash, 5 dash and 6 dash. Now in this case for outstroke it is SHM. Draw a semicircle. Divide the semicircle into equal angular divisions. This is 1, 2, 3, 4, 5, 6. Now draw horizontal lines from this angular divisions to this vertical lines of the x-axis. These points join smoothly, indicates SHM motion during outstroke. But during return stroke, it is the uniform velocity. How to do it? Drawing the line, during uniform velocity, it is a straight line. So join from this. Suppose these points as I shown before, A, B, C, D, E, F. It is F dash to this 6 dash. Join straight line. This is the motion of uniform velocity. This is outstroke. We did not follow the same points. We did not transfer here. Okay, because it is not SHM motion during return stroke. During return stroke, it is uniform velocity motion. So for SHM motion, it is like a straight line. Uniform velocity motion, it is a straight line. For SHM motion, it is a curve. So this is the displacement curve of a follower having a simple harmonic motion during outstroke and uniform velocity during return stroke. So I'm going to draw with the different colors. Red color. This is SHM, outstroke and return stroke. This is the displacement curve. Of a follower having SHM and uniform velocity. Okay. In this manner we can draw, but remaining procedure is same, but we have to consider the displacement while marking on the tangential lines passing from offset circle to the points of the base circle. On those points you have to consider these distances. F dash, this means E dash, it is a D dash, it is C dash, it is a B dash, it is the A dash, and it is. So these distance, vertical distance 0 to F dash during return stroke. During outstroke you consider 1 to A, 2 to B, 3 to C, D, like that, these distances. And return stroke you consider 0 dash to F dash, 1 dash to U dash. These points, vertical distance you have to consider and mark on the tangential lines of the offset circle, from the offset circle. And these are the points where the follower in contact with the cam. Okay, that is the procedure we are following. Now why we are doing here? We are getting the profile of a cam based on the motion of the follower. That is what we are drawing. That's why we have drawn based on the rotation of the cam. Cam rotation versus displacement, that is the stroke of the follower. So based on the displacement diagram, based on the contact of the follower, that contact points, if we draw the curve, that curve indicates the profile of a cam. Profile of a cam, or that is a cam profile we are doing. Okay. This is the motion, but remaining procedure is same. So we should be very cautious during outstroke, what type of motion of the follower, and during return stroke also we have to see is the same or not, or different. If it is different, we have to follow the different procedure for drawing the displacement diagram. So this is the complete, and remaining procedure is same for offset circle or for any follower. You can draw, if the for knife edge follower, it is remain same, the same displacement, but knife edge follower, you have to take the point of the knife edge case study. If it is a flat face, we have to know the flat face, the length of the flat face. Suppose the length of the flat face is not given in the problem, so how to take it? So we have to assume it for a length of 10 millimeter or 20 millimeters or 30 millimeters. But the procedure assumption based on the size of the cam, based on the size of the flat face or length of the flat face, the cam profile depends. Okay, it depends on the shape of the face, length of the face of the flat face or follower. So this is the procedure for a case to draw the displacement diagram when during outstroke the follower motion is simple harmonic, and during return stroke the follower motion is uniform velocity. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.